Good morning, good afternoon, good evening. I don't see any viewers, so this is kind of concerning. What I'm gonna have to do is go back out to the original link and see who's live. But my name is Charles Sterling. I am actually sitting upright. I put on a new shirt. I shaved all for you guys. And welcome to another one of our community webinars. This is the second using Google Broadcasts. Today we've got Casper De Young, who's actually going to look at modeling best practice. So Casper was one of the very first PMs I met in the BI space. Kind of actually helped me out getting started in the community. So I actually have a huge debt of gratitude for him. You know, as any good master ceremonies will have, is I'll have his bio, I'll have a lot of background on him, but I'm not a good master ceremony. I usually actually ask these guys to tell us a little bit about themselves as a result. But before we do that, let's do a little bit of housekeeping. Yes, this is going to be recording. Matter of fact, if you go out and take a look at the link, after we get started, you can actually see that you can go all the way back to the beginning because you can already see the recording as we're doing it live. Also, the Q&A has changed quite a bit from on 24. Rather than actually you posting questions, it's actually in a chat window where everybody, I'm gonna repeat that twice more, everybody can see your questions. So if you've got stuff about security and metadata that is sensitive to your own company, you may want to whitewash that and get that to us as a cleansed question rather than something that you might be embarrassed about sharing. So I'm going to be monitoring the Q&A panel. I'll be asking Casper questions that seem to be pertinent for everybody when he has a break. Otherwise, I'm going to hand it over to Casper. I'm going to turn off my camera. I'm going to mute my microphone, and I'm going to join the chat session. Oh, we have 87 people. It just took a little while to show up. We have 91 viewers, Casper. So a pretty good effort. And I know a lot of Microsoft people are internal. So before I hand you the microphone, I know that you wanted to talk a second ago. I want to let people know from Microsoft, inside of Microsoft, that we have both customers and yourselves. So again, when you ask questions, you might want to be sensitive to the fact that everybody's going to hear this and it is going to get recorded for the whole wide world. So Casper, over to you, my friend.
Thanks, Chuck. Good morning, good afternoon, good evening, everyone. My name is Casper De Jonge, and I'm a Senior Program Manager on the Power BI team. I've worked on the Power BI product for about 6 years. Before it was Power BI, I worked on Analysis Services. I worked on Power Pivot for Excel. And of course, I've worked on Power BI itself. I've worked on the Power BI desktop team. I worked on the Power BI APIs. So I really like talking about Power BI, and it's one of my favorite topics. And today we're going to talk about probably my most favorite topic. It's the data model itself. And we're going to look at all kinds of different aspects of the data model, because the data model is what feeds and what powers Power BI. It is used in every Power BI model. It is used in the Power BI desktop, and it's even used in our Power BI on steroids called Analysis Services in 2016. And in fact, that's where it all started. So most of the things that I'm going to show you today will work in Power BI desktop for sure. It might work in Analysis Services 2016, and it probably will. And I'll talk about, when we talk about each topic, then I'll talk about this. And it might work in Excel, Power Pivot as well. And I'll talk about this when we get there. But because some of the features are turned off in certain other environments. Or when we talk about Analysis Services, for example, Analysis Services is not as recent yet because it has already shipped, of course. So you can expect to see the same functionality and the same features show up in the upcoming versions of Analysis Services. Because the goal has always been Power BI and Analysis Services share the same engine. They're only a different matter of when they ship at what moment in time. So let's go ahead and take a look at what we're going to look at. So we're going to look today about to a few things. We're going to learn more about some of the new modeling concepts and constructs that we have in Power BI, and it have been added over time. And some of the things that we're going to talk about, and we're going to spend the majority of our time looking at this, is a feature called bidirectional cross-filtering. And bidirectional cross-filtering is something that was introduced in Analysis Services 2016 and with Power BI. The next one we're going to look at is a feature called variables, which is a really nice feature which allows you to do all kinds of cool things with DAX, but it's not well known yet. So let's talk about how you can use it and where you can use it. And as last step, we're going to talk about two other concepts that are very related to the model, but not necessarily modeling features. First one is, okay, when do I use DAX and when do you use M? And M is what you get when you use Power Query. So we'll look at what you should use when. And the last one, we're going to take a look at DirectQuery, and we're going to give you some power tips on how you can use DirectQuery to your best advantage and when you should think about using DirectQuery or not. So without further ado, let's start with bidirectional cross-filtering. And bidirectional cross-filtering is a feature that we added to Analysis Services and to Power BI Desktop. But to understand bidirectional cross-filtering, I'm going to take a big step back, and we're going to take a look at how relationships actually work inside of the Power BI model, because this is what we need to understand bidirectional cross-filtering and also understand why it's so important. So to do that, we're going to just start with a very basic schema, and we're going to look at an example. And what I have here is kind of like the optimal schema for Power BI. It is a star schema. And what we see here is we have a sales table called Internet Sales. That sales table has data, sales done by customers. Those customers have sales in a particular geography. The same sales also is being done, like you buy a product, and the product is part of a subcategory, and the subcategory is part of a category. And you can already see here what we have is what we call a star schema. It's not well formed as a star schema because it's not as optimal for the new white screens that we have today. So I put it like this, but in general, this is what it looks like. The screenshot that I have here is taken from Excel 2013. So you will see that arrows point in a certain direction in this diagram view. This is actually taken from the products. But let's take this model and actually start using it. So what I have here is a screenshot of one of our earlier versions of Power BI Desktop back when it was still called Power BI Designer. And I'm actually going to use that model that I just showed you. And the first thing that I'm doing is I'm dragging in English country region name. And what you see is it just shows up inside of this visual, which is of course very normal. Now, the next thing that I do is I'm actually also dragging in sales amount. And what it automatically does for me, it automatically shows me the sales amount summarized and grouped by English country region name. And also shows me a grand total. And it just works. You might think this is very normal, but I call magic. Because what just happened is we just dragged two things from two different tables together inside of a single visual, and it just gave you the right results by just dragging and dropping. You didn't have to write, if you're familiar with SQL, you didn't have to write a SQL query. You did not have to write select English country region name, comma, sum of sales amount from the country table, inner join sales amount grouped by English country region name. You didn't have to do this. You just drag two things together and it just worked. But how does it work? And this is where things get interesting. If you're an analyst and you just drag things together, that's great, and you can get things to work. But if you want to get your game to the next level, you try to understand how this works, and then you can put this to your advantage, because you can then, this is the power of the Analysis Services engine. There's also the same engine for Power BI. You can change these things. You can set it and you can model it, and you can change these things to your liking using DAX. But before we go there, let's see how this works, how we get to these numbers. So let's take this example. We have 1.9 million sales in Canada. How did we get to this number? We apply filters on every row inside of this table, and we sum the sales amount on the rows that are left. What does this mean? Let's go ahead and take a look again. So we start by looking at how data flows. And what you see here is the arrow points from one side to the many side, but actually data flows into this direction. And if you will see, and we'll take a look at this later, is that we actually change the arrows in Power BI Desktop to actually make it more easy to use. So what happens is, for this row, we filter the geography table on country name Canada. And what you will see is we have a geography table of 655 rows. And 655 rows are filtered down to just 73 rows for Canada. And the 73 rows of Canada is what's left and is being pushed into the next table. So now we will only see customers who live in the geography Canada. And it's using that relationship to do so. So again, the customer table has 18,000 rows. That 18,000 rows is going to be filtered down to just 1,571 customers. For convenience sake, I added the English country region name column on the right. You see Canada everywhere. This is not what it's actually doing because there is no region name column there. I added it for visual ease. But this table now also gets filtered down. Then, again, it gets pushed down into the internet sales table, and it's following the relationship. The internet sales table now will get filtered to only show me customers who live in Canada. And it starts out with 60,000 rows, and it gets filtered down to 7,620 rows. Of these 7,620 rows, what we're going to do is we're going to summarize the sales amount column that you see here. This is what's going to give us the end result. So it's filtered down. This is the end of the line. All the other tables are not filtered. This is how it's going to get me the country name filter, and this is how it's going to get me the 1.9 million. This is how it works. And this will do this for every row inside of this table. And we'll also do this for the grand total. You don't even notice, but the way that the engine is built using the column store index, it is super fast. And it's doing this like in a few seconds. This is what's happening under the covers. And it's summarizing these 60,000 rows in a blink of an eye. But what if we want something else? What if we want to know, because if life was all beautiful, then no one wanted to have different questions. They all wanted to do exactly what I wanted. Unfortunately, that's not the case. That's not what's realistic. So maybe they want to have a question like this. In each country, how many customers bought bikes? So now I do two different things I add to this pivot table. I add English product category name, where we can see bikes, and I'm dragging in count of customers. And you will notice something immediately here. You will see the same number is getting repeated over and over and over again. So you see different numbers for English country region name, but we see the same number getting repeated for English category name. So what's going on here? Why doesn't it work? It's trying to do the same thing. For this number, it's again applying the filters and it's counting the remaining customers. But as you can see, it's not working. So in this case, I have two filters, right? I have English country region name and I have the English category name. Those two are the filters. So I have the country name here and I have the category name bikes over there. And they're in two different tables. And again, that filter is being applied. And it's going all the way to the internet sales table. And now the internet sales table is being filtered by both country name and category name. And again, this is the end of the line. But what we want is we want to count the customers. And the customers are in that table on the top. And this is why we get the same number repeated over and over again, because the customer isn't filtered by product category. And it's just filtered by country name is Canada. So this is an issue. And we'll look into how we can solve this in a minute. But just to recap on how relationships in general work. Data is always filtered from the one to the many side. This works great in a traditional star schema. But what if we don't have a star schema? Or we want to count values in a dimension, for example, as I showed you just now? Then that doesn't work. Today, both Power BI and Power BI and Analysis Services will, when you create a new relationship, follow this. So we'll always filter data from the one to the many side, except when you have a one-to-one relationship. Then it works a bit different, and I'll show you this in a second. This goes back to why we actually started with this feature. This feature was actually started a couple of years ago, before we even started the whole Power BI and Power BI Desktop train that we're on today. This was mostly focused to solve the many-to-many pattern, which is very much related to what we talked about just now. The many-to-many pattern is a pattern that you can solve today with using multidimensional models, but you cannot solve, or you could not solve, before using tabular models and Power Pivot. And traditionally, the many-to-many pattern is like this example. And actually, I took this example from a 2009 white paper that was written on multidimensional. And what it will do here is it will do a few things. What we have here is we have a customer, and the customer has one or more accounts. And one account has multiple transactions. So this means that a customer can have multiple transactions, but one transaction can also have multiple customers. And this is what we call many-to-many. And what will happen today is, if we were to put this in, again, a pivot table, you would see that we have, I put customer on one side and I put the sum of amount on the other side. And again, you would see the number would get repeated over and over again. Because, and again, you see the different arrows that I show here. This is actually what is running today in Power BI Desktop. You see the star and the one. It says many to one, and also shows you the arrow pointing which way the relationships flow. And again, you will see we try to filter by customer Henry Waxman. That customer goes to the customer account table, Henry Waxman. You see that gets filtered. That's great. But now it stops, and it doesn't allow me to get filter into the account table. This is why we get the number repeated over and over again. So how do we solve this? Well, before we introduced this feature in SQL Server 2014 and 2012, and in Power Pivot, the way we would solve this is by using DAX. And of course, I'm a DAX guy, so I love that you can solve a lot of things with DAX, but this is pretty complicated stuff. Actually, Marco and Alberto wrote a white paper on this called the Many-to-Many Revolution, and it actually goes into a lot of details on how this actually works. But the good thing is, you can forget about it, because now you can actually use Power BI Desktop and just solve it easily. The downside here is, yeah, it's complicated and it only works for a single measure. Now, with Analysis Services 2016 and Power BI Desktop, this is the Analysis Services 2016 screenshot, and I'll show you the Power BI one in a second. But now you can actually go in and say, okay, instead of having the filter direction go into one way, I want it to be able to filter both ways. So now here, I go in here and I can turn on the bidirectional cross filtering. As you can see here, the arrow in the middle now points into two directions. So now you can see the customer account filters the account table, which filters the transaction table. And now we see Henry Waxman has one transaction of 150. Jane and John Hanover together had one transaction in their shared account of $100. So you see, they both have $100. The grand total is 250. This is not the sum of all the rows above. This is the sum of the two transactions, the joint account from Hanover's and the one transaction from the Waxman, which sums up to 250. And we're just changing that relationship from the top one to bidirectional. We solved this problem. There was no DAX needed. It was pretty straightforward and simple. So now we can solve the many-to-many problem. We debated a lot on how we would call this feature. Are we going to call this feature many-to-many? And the reason why we didn't call it many-to-many is because it actually allows us to solve much more problems than just this one. And I'll show you this next. But also, the other big problem that we had is that many-to-many actually means many different things to many different people. If you talk to a database guy, many-to-many will mean different things than when you talk to a multidimensional guy who's used to build models in multidimensional, and so on. So many-to-many can mean a lot of different things. It's ambiguous. So we decided to call the feature that we introduced bidirectional cross-filtering, because that's what we're actually doing here. We're filtering not just from the one-to-the-many side, but we're filtering to both directions. So if you put a filter on, as we do here, on the customer account table, it actually also filters the account table, where normally if you put a filter on the account table, it will automatically only filter the customer account table. So this is what we call bidirectional cross-filtering. So let's take a quick look at a demo. So what I have here is a Power BI desktop file, and you see the same Jane and John Hanover and Henry Waxman we have here. The total adds up to 250. On the bottom, you can see we actually have two transactions, and we have one account and the other account, and again, yeah, two transactions, and it doesn't work. Of course, what we can do here is we can go in and add the measure. Again, it's the same measure I showed you earlier. I can just go in and add the measure, and this measure will now show up as says 100, 100, and 150. So now it works. That's great. But again, this is just for a single measure. So what I want to do is I want to go in and just change the relationship. So again, I go back to my diagram view, the same one that I showed you earlier. And what I can do now is I can double click on this guy and go to my cross filter direction and set it to both. Now you will be able to press OK. You will see now the arrows are pointing into both directions. And if you go back, you will see that now the sum of amount magically started working. And we've solved this problem. This is great. This was a very hard problem that we never really were able to solve without writing complex DAX before. Now you might think, okay, this is great. I'm just going to turn on bidirectional cross-filtering everywhere because it just solves my problems. Unfortunately, that's not the way it works. So let's go back in. Oh, but before we go there, let's take a look at one more example. Besides the many-to-many problem that we were talking about before, the other problem that we can solve is that we can allow us to solve is using a measure in a dimension. And this is a variation of the theme on the first thing that we showed you. What we do here is we have the sum of sales amount from the fact online sales table, and we have the unique products from the dim product table. And what I can do here now is I can drag in my year and from my date table. As you can see, it's one-to-many, so it automatically filters the fact online sales table. That will automatically get filtered. And you can see the sum of sales amount shows me the right numbers. The unique product gets repeated over and over and over again. And again, this is because the filter doesn't flow into this direction. If you take manufacturer, for example, as well from the product table, you will see that the manufacturer actually gets filtered. So you see Datum Corporation, 132 products, Adventure Works, 192. So that's getting filtered. And you also see that the year is automatically also getting filtered. So the sales amount from the fact online sales table gets filtered by both. The product only gets filtered by one. And again, easily solved by turning on bidirectional cross-filtering. Now the product table is also filtered by any filter that's putting on the fact online sales table. And you might already start to see where this is going. Because imagine that I had much more dimensions around it, which in this case I probably would, which says a promotion, which stores, which and so forth. Then all those filters that are getting applied automatically also filter the product table. Is this a good thing? It's up to you to decide as a modeler. So what is a good thing and what is a bad thing? Because the problem that you will face is something that we call ambiguity. And ambiguity means, there's confusion of what it means. So let's take an example of what this ambiguity would mean for us. So let's take this schema. And again, this was a schema. Was something that was possible at one point. I have a build where I can do this. But in this case, what I want to see is, okay, we have stores. The stores are in regions. and in that region lives a customer. It almost sounds like a fairy tale, but we also have stores who do sales to customers. So interesting. But what I do now is I drag in the store name and I drag in the count of customers by that store name. But what do I mean? Unfortunately, the analysis services engine cannot read your minds to guess what your intent is. Because do you want to see the customers who live in the store's region? This path. So we filter the store by the store name that you selected. Then we filter the regions by the store that's being selected. Then we filter the customers to just show those customers who live in that, who are in that region of that particular store. Or do we want to see customers who bought something at that store? So we see it by the sales that they've done in this particular store. Or do we want customers who live in the region and bought something in the store's region? This is also a possibility. And frankly, we would never know. You would drag this together in your pivot table and then we would never know. So actually in one of the earlier prototypes that we did with this a couple of years ago, we actually tried this out, that we would ask you questions. Say, do you mean this? Do you mean this? Do you mean this? The big problem here is that we would get a mess quickly when your model starts to become really big, especially in cases like analysis services. The other interesting thing, of course, is that we need to give you a tool, a visualization tool that actually allows you to ask the questions and react to it. So we decided to not go for it. What we now do is you cannot get into this state. You need to have a non-ambiguous cycle. So in this case, you can do it like this. So in this case, you would see one dotted line, which is an inactive relationship between region and customer. So it's turned off. In this case, it means that you have the count of customers who buy something in this particular store. The modeler has decided this is what you want. Of course, things get interesting when you do want something else. So you do want to see the customers who live in the store's region. Luckily, the escape hatch is always here. It's called DAX. So what we have here is something that we call the DAX cross-filter function. And the DAX cross-filter function allows you to specify the cross-filtering direction to be used in a calculation for a relationship that exists between two columns. It's very similar to our already existing use relationships function. So we already have a relationships function that allows me to turn on or off relationships. So I can say, instead of using this relationship, use this inactive relationship over here. Commonly used by when you have a single date table and a single fact table, but you have 3 different dates: order date, due date, ship date. You do want to allow them to be able to see it in all those flavors. You can add measures to do this using the use relationship. That same would work for the cross filter. So you can say cross filter this column name and this column name in a particular direction. Do it single directional, do it multi-directional, both, or don't do any cross filtering along this relationship, meaning turn it off. So if you go back to this previous scenario here, what I want to do now is I want to turn off the relationship between sales and the customer table, that line that you see running between them. And instead, I want to activate the dotted line between region and customer. So when we look at what this calculation would look like, is you would get something like this, where you would say, calculate this particular measure, turn off the cross filter direction, and use this other relationship between the region, customer region ID and the region ID. And this would allow me to give me this number. So I can create measures that allow me to deviate from the common path that the data model would generate for me. So again, this goes back to the early beginning. If you understand the capacity and the things that the model can do for you, you can start playing with it. You can start changing this using DAX. So instead of the common path that is what you model for, you can say, okay, for this measure, I want to do something else. This is similar. I always say, if you want to really learn how to model and to use the best of the analysis service model, there's two things you need to learn. One is relationships and how they work, because then you understand theoretically how everything works together. And the second thing is filter context. This is a DAX concept, very well explained in many of the DAX books and the DAX sessions, so I won't go into too much into that here. It will probably take me an hour, half an hour to just explain that. But that's the other common thing that you do. If you understand these two, then you can model almost anything. All right, so ambiguity is one problem. The other problem that you might have and run into is something we call overfiltering. So here we have another schema. This one is actually fully possible. You can create a warehouse. So in this case, you can create this today in Power BI Desktop. And what we have here is what we call W schema. And you have multiple fact tables, an inventory and a sales table, and 3-dimension tables. What we have here is a warehouse. The warehouse table gives me the inventory that is put in a particular warehouse. That inventory is meant for a particular store. The store has sales done, and the sales are done by a sales manager. So they're all related to each other. As you can see, I've turned on bidirectional cross-filtering here on all relationships. This is allowed. This is okay. Power BI will not complain about this. If you go back and into the previous step and you look at the ambiguity example that I showed you earlier, and when you try to create this, Power BI will give you an error message saying, hey, you're trying to create an ambiguous schema. You can't. Here in this case, everything is okay. But what is it actually going to go do? It's going to overfilter. So imagine this. Again, I have a pivot table where I'm dragging the warehouse in, and the warehouse again creates a filter by warehouse. If I now want to see sales managers, I won't be able to, because what will happen is I will see the warehouse, it's getting filtered down, and it's going to filter me the inventory table by warehouse, which is okay. This is when we understand. But then it's only going to show me the stores where I had inventory for this particular warehouse. After that, it's only going to show me the sales for stores where I had inventory for this particular warehouse. And as last step, it is only going to show me sales managers where I have sales in a store where I had inventory for this particular warehouse. Already, it starts to get daisy. I start to get dazed about what the consequence of what this means. And they only have 5 tables here. Imagine you have 50 and you turn on bidirectional cross-filtering. You're going to be really, really hard-pressed to understand where all of this is going to and how this all works together. Not to talk about performance as well, and we'll get to this in a second. So overfiltering with multiple fact tables is a potential issue that you might run into. Of course, this might be exactly what you want, which in this case is good, but you have to think about it. And this brings us back to kind of like the last thing about relationships and bidirectional cross-filtering is you have to be mindful of what you do. In general, bidirectional cross-filtering will be slower than single directional, as you can imagine, because look at this case, where in the past, when you would single directional, when you put a filter on the warehouse table, it will only filter down the inventory table. But if you turn on bidirectional cross-filtering, the analysis services engine has to filter all of it, all the time, which might be an issue, right? This especially gets worse when you turn on DirectQuery. And we'll get to DirectQuery in a second, but I just wanted to mention, or as the last topic, but as you can imagine, instead of using the analysis services engine that is in memory, that is built to do these kinds of things, you're actually asking the underlying database system to do, instead of an inner join with 2 tables, warehouse, and inventory. You ask him to do an inner join with 5 tables. It's going to be slower. So you have to keep that in mind when you do DirectQuery. Then the other potential problem is there's a potential of overfiltering when using multiple fact tables. So in general, I would say only turn on bidirectional cross-filtering when you need it. So this means that, and again, this is one of the lessons that we learned for Analysis Services 2016. We already turned off bidirectional cross-filtering by default. So when you create a new relationship in Analysis Services 2016, it was turned off. So when you wanted it, you had to go turn it on. With Power BI Desktop, we started with turning it on. But we quickly went out of it and said, okay, okay, we're going to turn it on. We're going to not turn it on by default anymore. Going forward, we're going to turn it off. So from this day forward, and I think it shipped probably a couple of months ago already, when you create a new relationship inside of Power BI Desktop, it actually will create a single directional, not a bidirectional. So you have to go think about it to turn it on instead of it automatically being turned on. So this is in short, relationships and bidirectional cross-filtering. I think, Chuck, we might want to do a few questions if there are any.
You know, Jorge and Simon have been answering them in real time, so I think we're pretty good. I want to, you know, the awesome. SQL Chicken has been working his ass off for you, so we need to give him a shirt or something.
Good, thanks, guys. All right, so then I'm going to go talk about the next topic. The next topic is, quickly, let me go here. The next topic is variables. And variables is something also interesting that we added to the Power BI/Analysis Services engine. And the Analysis Services Power BI engine has gotten this feature not because customers asked for it. We built this feature for ourselves. And we built this feature so we can get better performance. Internally, we created a new project that we call SuperDAX. And SuperDAX is something that has allowed us to improve the query performance between the visualization layer, previously Power View, and the Analysis Services engine. The Power View engine was generating DAX queries that were not so optimal. Those queries that were generated were very chatty in nature. So one visual would potentially generate 20 to 40 queries to the Analysis Services engine. So by introducing a lot of new concepts, and the biggest one is the variable concept, we were able to reduce the chattiness between the visualization layer and the Analysis Services engine by a lot. So instead of having 40 queries, we can now probably get done with 2 or 3 queries instead to get all the values. So we actually built this feature for ourselves, but we shipped it. This feature is available in Analysis Services 2016, and of course everything that comes after. So when I say Analysis Services 2016, it also means vNext of Analysis Services and Analysis Services in Azure, where this also is going to be available. And variables are also available in Power Pivot for Excel. So Excel 2016, and I also, in Excel 2016 is also available. The bidirectional cross-filtering that I talked about earlier is only available in Analysis Services and Power BI Desktop. It is not available in Excel. Variables are. So what do variables do? Well, variables are this new construct in SQL Server 2016, Excel 2016, and Power BI. Variables are measure bound. They can only be used locally in a measure. And I only have to put this here for the developers among us who are used to be a developer. You can define it once. You can define a variable once inside of your application, and you can reuse it many times. In this case, you can only define a variable inside of a measure, and you can only use it there. Once you return it, it's gone. It's out of memory, and we'll show you this in a second. The cool thing about variables is you can actually store single values, columns, or entire tables in memory in this variable. It's a great way to improve performance and reliability. Well, the last thing that we have to remember is that because they're measure bound, you can still only return a single value in a measure. You will not be able to create a table and return that in a measure. Because when you would use this measure inside of a visual, the visual would explode. Like Excel wouldn't know what to do with it, Power BI wouldn't know what to do with it, because they always expect in a single cell this value to be returned. What does it look like? It looks like something like this. And this also kind of shows you where the benefits are. Because what I have here is a measure, and the measure name is var1 equals expression, var2 equals some expression, and it doesn't really matter what it is. It's a DAX expression. var3 uses those two variables I defined before. And it would say if var1 is larger than 10, then divide var1 by var2, else variable 2. And then the end will return the variable to the measure name, and this is what's getting returned to the Power BI. Now, the interesting thing here is, if I would have written if and then replace var with the actual expression, what this would mean is that the expression for variable 1 would actually be executed twice. So let's say it was sum of sales amount, and this is a very simple, straightforward example. In this case, it would say if sum of sales amount is larger than 10, then divide sum of sales amount by something else. Now, sum of sales amount would have been calculated twice. For sum of sales amount, this is okay because the analysis service engine is fast enough to do this. But when you use variables, the value of sum of sales amount, the result, is getting stored inside of that variable. And that result of this variable is actually what's getting used inside of this expression. So instead of sum of sales amount being executed twice, it only gets executed once. So this is already a performance improvement. Now imagine that you would do a very complex expression like a sum x, product x, and it will iterate heavily over some group. I don't know exactly what it is, but you can use expressions and variables to reduce the amount of calls that you have to do to the analysis service engine and that it has to calculate. So this is a great way to do performance enhancements. So this is another example here that I can actually use my variables inside of an expression. For example, here what I can do is I can create a measure. I can use the product x function to iterate over the first variable. In this case, it's a table expression. And it can do whatever. And I'll show you some examples later on about these things, but I can do a union, I can do a filter, I can get this table, I can do something else over this table, and I can return that table var, and this is what's getting iterated upon. Then in the measure part of the product x function, I can use new measures, and I can reference each other. The important thing to recognize here is that once you've done return of something, that measure is gone. And you have to do return here because it has actually two arguments on the product x function. So it needs to get returned. They cannot be persisted over the boundary of the two. So this is one example. Let's take an actual look at some examples here. So here I have a year-over-year growth by calendar year. And it's a very simple expression. It does something like this. It does sales year over year. And it says if sum of internet sales amount is larger than 0, then divide sum of internet sales amount by the sales amount of last year. Very straightforward and simple. The interesting thing to remember here is that now sum of sales amount is actually calculated 6 times. For every cell inside of this table, 2006, 2007, 2008, this measure is being executed. In this measure, the sum of sales amount is calculated twice to determine if it's the if or the else branch. And then in the if branch, it's going to calculate the sum of sales amount again. So, and actually probably is calculated more than 3 times because the if part is actually calculated also for 2009 and 2005, but you don't see them here because they return empty values, and you will never see them. So in this case, we can optimize this by using variables. And I'm using the same measure, but now written using variables, and I'm putting them side by side. You see they actually return the same values, which is great. But now I've written them as a variable. And what you will see here is, and you will see var sales, and let me quickly see if I can zoom it real quick. And we do here. All right. You will see sales year-over-year percentage variable equals var sales is sum of internet sales amount, and returns if sales is larger than 0, then divide sales by sales last year. So now you see that that sum of sales amount is being put inside of a variable, and that variable is used twice. Again, a performance improvement here. I also like it because it's much more readable, and you can easily do some debugging and playing around with it as well. This is one example. The other example, now things get a little bit more esoteric, if you will. Here, I've written something that does something like this. It creates a variable of a table union, and it unions two different things. One, it unions the customer key from the customer table with the customer key from the fact internet sales table. So you have two table results. I union them together, and then I return the count rows of that union. Again, not sure why you would need this right now, but this is something that could be interesting at one point. So you can start creating new tables in memory and iterating over that before you actually start returning it. The same thing goes here when I go to test var2. It's something like this. And again, this is even more fake. But what you will see here is test var2 is the sumx of table variable currency name. In this case, I'm just getting return all the currencies. And for all the currency names inside of this table, I'm doing a count rows of the table, and I'm doing it times 1.5. Again, this is fake, but just to show you kind of like things that are possible. And the last one, and I really like this one for usability, for readability, is that you can actually use variables inside of filter arguments. So what I'm doing here is I'm showing us the sales for the last 12 months. And the first thing that I'm doing is I'm determining what the sales of the last day was that I had sales. So what I'm doing here is I'm doing a calculate, and I'm getting the last non-blank value for the due date based on top of the sum of sales amount for the entire table. So this would give me the last due date that I had sales in the entire fact internet sales table. And I'm putting this in the variable. The next variable, what I'm doing here is I am generating a list of dates based on the due date table, based on the last day of sales variable that I created before, and the last day of sales 365 days ago. I'm just using minus 365 days. It is a variable, so it also doesn't have a data type, but it already knows that it's a date. So it automatically allows me to do this kinds of stuff. So now I have a list of 365 days based on the due date. And then the next thing what I'm doing is I'm counting the effectiveness sales table, the rows of the internet sales table, for every day of the last 365 days. So it's giving me the returning of these values. And again, what I'm doing now is I'm using variables as an argument on the filter on top of the calculate. Again, it's really easy, and it's more easily for me to read these things and also to like build up my expressions. And for debug purposes, what I can do is I can just, instead of return a count rows, I can just return a variable and see what the number is for this particular cell. So it's really easy for me to debug this. All right. So these are some of the examples that allows me to work with variables. And again, variables are for readability purposes, but also it's really, really worth it to look at your complex calculations that are expensive to see if you can optimize them. We use it all the time. If you want to learn really how you can use variables, I would recommend you to go ahead inside of Power BI and see the kind of queries that are being generated. And you can do this by going into here, go to File, File, Options and Settings, Options, and then you go to Diagnostics and click on Enable Tracing. And Enable Tracing will do two things. It will create files inside of the Traces folder here. You can open it, you can see all kinds of files that are being added here. The big thing, and I don't have one generated yet, but the big thing that you will be able to do here is there's also going to be a trace file that's going to be added. You can open this with the Analysis Services trace, the SQL Server Profiler, and you can actually see all the queries that are being sent by the reporting canvas to the Analysis Services model that's sitting under the covers. And now you can learn what kinds of queries are being generated. So this is pretty cool and will allow you to give some ideas on how the masters who actually built both the DAX query language and the visualization layer generate their queries. I always go to them as well if I'm in trouble with something in DAX. So you might learn something. All right, Chuck, any more questions on this one, or do we have it covered as well?
No, we're actually still looking real good.
Great. I have 2 more topics and 10 more minutes, so that's good. All right. One other very important topic that we get asked a lot, I get asked a lot, and everyone else that I know is getting asked this a lot, is when do I use DAX versus when do I use M? Of course, M is the language that is generating Power Query. It's a very powerful language. So the first thing that we have to know is DAX versus M discussion is only applicable when you have a calculated table or calculated column scenario. DAX can be used in 2 different scenarios, as you probably all know. One, as a calculated column table scenario, where when you use a DAX expression, that outcome of that expression will actually be stored inside of the model. It's static. It will only be calculated when you refresh the model or when you create it. For the rest, it will never be changed again. Measures are different. Measures always run on the fly. They allow you to do something like I just showed you in the previous example, where you just want to get the number by year aggregated automatically. But if you swap out a year for products, it will still work because the measure is calculated on the fly. If you create a calculated column, this will not be the case, and this will already be stored in memory. So we have calculated table column scenario, and measures are running on the fly. The Power Query /M allows you to do data ingestion well. This is what it's built for. This is what it's designed for. So M and the Power Query language is built to wrangle data on ingestion. And wrangle data means you can use all the great capabilities that it has in it. Capabilities that I've always wanted when we had Power Pivot without M. Things like unpivot, upper, left, all these things are very easy to do inside of the Power Query engine. It's easy to do. 2, there's a lot of different new things that you can do. But the third one is very important as well. And I know I made a typo here, but M will push as much of this wrangling down to the data source. It's called query folding, not data folding, but query folding. This means that when you do an upper, for example, you want to uppercase your column instead of the lowercase version of it, you use the M function to do the uppercase. But under the covers, what the Power Query engine will do is it will translate this into a SQL upper query. And it will ask SQL Server to give this uppercase instead of doing it itself. The DAX engine would do it themselves. It would import the lowercase version of it. Then it would make an uppercase. So it would be much more perfect on the Power BI engine, where this one will be hit on the data source. M can only reference values in other columns of the same table. There are some exceptions. You can go to call functions and do all kinds of things, but in general, M can only reference values in other columns with the same table. M is designed for wrangling data. This is what it's great at. I just want to make one statement on the bottom. These are general statements. There are, of course, exceptions. It's never as black and white, but in general, we would say M is good at data wrangling. DAX can be used to wrangle data after ingestion. The downside is DAX will do all the wrangling in memory. Perf hit will be on the model itself. So it will be on your Power BI desktop file. It will be on the Analysis Services engine when it starts supporting when it does DAX. The good things is DAX can reference data anywhere in the model by following relationships or lookup value. So if you want to create a new table based on data that's already in your model, well, then you can use DAX. But DAX is designed for analytics. The reason why we have all these data wrangling features, like left, right, upper, all of these things, is because we took a copy of the Excel code base at one point of all the functions and pasted it inside of the Analysis Services engine. And that's why we got them all for free. So DAX is designed for analytics. So in short, the takeaway is, in general, you need to use Power Query on M when loading data from the data source into the model. And this is the general what the UI of Power BI would allow you to do so. But if you create a calculated column, think about it, what you should do. Because when you create a calculated column inside of the Analysis Services engine, inside of the Power BI desktop, you're eating up more space, and you have to calculate it every time you refresh. So your refresh will take, every time you add something, will take a bit longer. Where when you use M and Power Query to do this, sometimes you don't even have to pull in the original record. You can, if let's say in the case of upper again, you have a column and you have the uppercase version of the column. You can actually remove the lowercase version of that column from the Power BI desktop site, and then it will actually never get imported into Power BI desktop. So this will save you some data size. When you already have the data in a model, you can use DAX to query upon the data. So in general, use M and use DAX where needed. Again, think about when you want to use one over the other. But in general, use Power Query. Okay, last topic, and then we'll stop for questions because we only have a couple of more minutes to go. The other interesting topic is called DirectQuery. And I assume most of you who are watching this are aware of what DirectQuery does. But in short, what it does is, instead of using that Analysis Services in-memory engine, the FruityPack engine that I talked about before, we would use the underlying data source. It would send queries to the underlying data source instead of using the embedded engine. And it's used for a lot of good cases. Customers do not want to wait for data to load into Analysis Services. They need real-time data. It needs to be happening all over once. They don't want to move the data because that's what they heard from the big data world. They don't want to move the data. They just want to keep them in place, or it's too big, or things like this. In general, they trust their data source to handle performant analytical query patterns, concurrency, and security. So this means that, and I've seen these cases happen when someone thinks, oh, I have this OLTP system over here that I've built for my store, and I'm now just going to enable DirectQuery on top of this. It will be fine. Well, that database works well for your store and for your store system, but now you're unleashing all the analysts inside of your organization to run all these queries against it as well. It might not work. The same thing goes for concurrency. Well, your Spark engine might be fast when it returns a single query, but once you start generating 6 visuals on your report for 100 people inside of your organization, your Spark engine will not survive. So you have to think about this, because many of the underlying data sources are not ready for the onslaught that is being created by the visual query patterns. Of course, you can make it happen. You can make it work. We really have to think about it. The thing that I wanted to point out here as well, we just released a white paper on DirectQuery and Power BI, mostly on Analysis Service, but also works for Power BI, that you can start using here as well. All right. So there are some tips for you to use because you can make it fast. You can make it work if you know what you're doing and if you optimize your data source. The first thing is we want to make sure by default we send left arrow joins when we generate the query. So in this case, for example, if I want to have the region country name and discount, what it will do between these three different tables, it will generate left arrow joins. And why is it doing this? It's because by default, the Analysis Services engine will never discard any data. So even if you have referential integrity problems, for example, you might have sales that you don't have any customers for because you had referential integrity problems. I know, of course, this never happens, but in reality, it does. So the Analysis Service engine would automatically do is show you an empty row in the dimension table and shows you the missing sales there. So we'll never throw away data. If you convert this into SQL land, with the SQL queries that are being sent now, is that instead of the inner join, it would actually do a left arrow join. But if you trust your data and if you know your data, you can swap it from a left arrow join to an inner join by turning on assume referential integrity. You see the highlighted part on here. So when you have a DirectQuery model inside of Power BI Desktop, you can turn this on. This will switch from a left arrow join to an inner join. I have seen performance go up 4 times. So we became four times faster. That's tip 1. Tip 2, and we've already covered this, so I'm going to kind of skip this, but use bidirectional cross-filtering sparingly. Because again, it's going to start creating inner joins on many different tables. Power trip 3 is, can you understand the security requirements? Row level security is very expensive. And again, and I'm actually working on updating a white paper for security as well, which will be out in a couple of weeks, but we'll cover this there as well. What you will see is when you create row level security, for example, you put security on the user table here, we automatically filter again 4 different tables, which is probably what we want. But again, now if I want to look at sales data, I always have to do an inner join of all those 4 tables, always. Is this what you want? Is this what you need? Maybe, I don't know, but it's something to think about. There are some ways that you can optimize this. Can you maybe move it to the data source or simplify it? Today we cannot use row level security from the underlying database system, but pretty soon we will allow you to do so inside of Power BI. You can already do this today with Analysis Services. All right, last one, Power tip 4, it's consider your DAX. A calculated column will be calculated every time you use it. You can do it, but maybe you should push it back to the data source. How much data are you pulling in with your measures? Can you offload these to your data source? And then the last takeaway, before we close, is this all worth it? Yes, you can do it with DirectQuery against the data source directly. But the VertiPack Power BI engine is relatively cheap. A small server can handle a lot of data and tons of data. And it can handle all your analytical needs. It is built for it, the blazing perf, measure, joins, concurrency, all of this, it can take care of it. So a relatively cheap Analysis Services engine compared to a very, very expensive data source that can handle the same load. So you have to think about, is this worth it? And with that, I have come to the end of my presentation. I think we're a few minutes over, Chuck, so I'm going to give it back to you.
Thank you very much,
maybe
Casper.
You can answer some questions.
You know, since we're over time and SQL Chicken, Jorge, and Simon Noose has done a great job, I'll just ask one last question from Teka, who happens to be from the Netherlands. He lives near you somewhere. He's wanted to know if if the M language is coming into other services like SSIS.
So I don't know. What I've heard is that they're thinking about it, but they have been thinking about it for a long time.
Yeah.
So yeah, I mean, I know they want to do it, but I'm not sure when it's coming.
Gotcha. And I already told Tieko that you're not on the team, so we wouldn't probably be able to comment anyways. But thank you very much, guys. I want to thank the 130 people that joined us. And of course, this recording is going to be available for you already, as a matter of fact. So with that, I'm going to go ahead and stop the broadcast. And next week, we actually have a new announcement for Flow. So the community webinar is on Microsoft Flow. And as me and Casper were talking about, it actually does great Power BI integration. So I hope to see you guys next week.
Great, thank you.